Computer audio. All right, looks good. 1 minute. I'm trying to make sure everything is synchronized. This has an agenda. So moving forward, I'm gonna try to type these up, but I wrote it out. And it's a lot of planning that goes into getting these recordings ready for you guys, for your students. So I hope you take advantage of it. Also, moving forward, I'm gonna try to get the message out there that you can literally log in on Zoom, as well as, log in on Zoom via your cell phone or your laptop if you have one, or even a tablet. For what I've seen, I'm trying to investigate as far as what's the phone number so you can call in, because there are a lot of people that I know from higher education and post-secondary education, high school basically, who use Zoom. So yeah, I know it got hacked and everything, but listen here, you can log in and ask questions and move forward. This will be a way to help you recover credit from previous assignments. That's what I'm trying to do on Wednesdays and Fridays, all right? So this video is going to be based on electromagnetism. And there's a whole agenda. Like I said, I'll try to move forward, get it typed up and sent out beforehand. But honestly, the first part of the agenda is watching a video, which is about, I want to say, 4 minutes and 35 seconds long. This is watching Tesla unveil its full self-driving computer in under 5 minutes. Now, why is this important? We are talking about the chapter 23 of your physics books, which I know you don't have them because they're in the school and they're under quarantine. But chapter 23 discusses electromagnetic induction. And that centers around Nikola Tesla. He was I think he was an electrical engineer, and he came up with the idea of how we can use magnets and a little bit of electricity to make motors and generators. And motors and generators is something we're talking about with the calculations here. But I want to start with the real world application first, let you see exactly why it's beneficial to learn this calculation and why is it my focus. I'm a former electrical engineer from Illinois Institute of Technology, and I'm also a nuclear physicist from Chicago State University. So with all that said, you know, all the science involved, this is important, and this is what I'm utilizing as an extra credit assignment to also, you know, get you privy to how 4 degrees in trigonometry is going to be beneficial. Because we're going to talk about cosine, not tan, not sine, but just cosine, and what theta is, and it's going to be a lot of terms in there, but we're going to try to go through it. So let me start with the video first. I'm going to share a screen so you can see the video, and there'll be extra credit for students that actually can give 2 to 3 paragraphs explaining why this application is beneficial during these current times. So hold on 1 second. It's gonna figure, I think I got the hang of Zoom at this point. So I think if I do this, there we go. So you should at this point see my screen. We'll put it on full screen real quick and play the clip.
How could it be that Tesla was an evidence that it showed before, we designed the best chip in the world? But that is objectively what occurred. Not best by a small margin, best by a huge margin. It's in the cars right now. All Teslas being produced right now have this computer.
Back in October 2016, Tesla announced that its vehicles will start shipping with cameras and sensors to support fully autonomous driving through a software update and computer upgrade to come. According to Elon Musk, that day has arrived.
All cars being produced have all the hardware necessary, compute and otherwise, for full self-driving.
Tesla held an event for their investors called Autonomy Investor Day at their office in Palo Alto. The event showcased software upgrades to Tesla's self-driving technology to be rolled out in a series of over-the-air updates. As of now, Tesla's autopilot feature enables self-driving on highways, on-ramps, and off-ramps, with periodic input from the driver. Tesla CEO Elon Musk also debuted a new computer called the Tesla FSD, or Full Self-Driving Computer. Previously known as the Autopilot Hardware 3.0 upgrade, The FSD is said to be currently in production and will enable Tesla's software updates to work.
Here's what it looks like. I'd like to point out that this is actually a pretty small computer. It fits behind the glove box, between the glove box and the firewall in the car. It does not take up half your trunk. As I said earlier, there's 2 fully independent computers on the board.
And the general principle here is that if any part of this could fail, and the car will keep driving. So you have cameras fail, you can have power circuits fail, you can have one of the Tesla full self-driving computer chips fail, car keeps driving. The probability of this computer failing is substantially lower than somebody losing consciousness.
There on the top left, you can see the camera serial interface. We can ingest 2.5 billion pixels per second, which is more than enough to cover all the sensors that we know about.
In case you use, let's say, LiDAR, would it be able to process that?
LiDAR is a fool's errand. And anyone relying on LiDAR is doomed. Doomed. Expensive sensors that are unnecessary. It's like having a whole bunch of expensive appendices. Like one appendix is bad, well, now we're a whole bunch of them. That's ridiculous. You'll see.
All autonomy, because you want level 4, level 5 systems that can handle all the possible situations in 99.99% of the cases. And chasing some of the last few nines is going to be very tricky and very difficult. It is going to require a very powerful visual system. So I'm showing you some images of what you might encounter in any one slice of that 9. So in the beginning, you just have very simple cars going forward. Then those cars start to look a little bit funny. Then maybe you have bikes on cars. Then maybe you have cars on cars. Then maybe you start to get into really rare events like cars turned over, or even cars airborne. We see a lot of things coming from the fleet. And we see them at some rate, at like a really good rate compared to all of our competitors. And so the rate of progress at which you can actually address these problems, iterate on the software, and really feed the neural networks with the right data, that rate of progress is really just proportional to how often you encounter these situations in the wild. We encounter them significantly more frequently than anyone else, which is why we're going to do extremely well.
We have 8 cameras, but then we also have additionally 12 ultrasonic sensors, a radar, an inertial measurement unit, GPS, and then one thing we forget about is we also have the pedal and steering actions. So not only can we look at what's happening around the vehicle, we can look at how humans chose to interact with that environment. And so I'll talk to this clip right now. This basically is showing what's happening today in the car, and we'll continue to push this forward. So when you start with a single neural network, we see the detections around it. We then build all that together with multiple neural networks and multiple detections. We bring in the other sensors, and we convert that into what one calls a vector space, an understanding of the world around us. And this is something where, as we continue to get better and better at this, we're moving more and more of this logic into the neural networks themselves. And the obvious end game here is that the neural network looks across all the cars, brings in all the information together, and just ultimately outputs a source of truth for the world around us. Does full self-driving capability make you want to purchase a Tesla more?
Okay, so that was a quick vid. Let me stop that. Stop. All right, so with that said, let's go back to the assignment, right? So now we're at the part of the agenda where I'm going to use this electromagnetic induction review from chapter 23 in ESV to review, something that's very important in terms of talking about that self-driving vehicle, which is a Tesla Roadster. When it says self-drive, you can literally get in the car and it, due to GPS, Global Positioning System, allows you to get to your destination by programming. So how does the car work though? Well, in my former years of working at IIT as an electrical engineer and in hybrid vehicle technologies, you have to understand that there's a process called electromagnetic induction. And this is the chapter we're talking about. So this is especially important for physics students as a prerequisite. I want to say, I made some notes, our robotics, ECS, I'm gonna try to get into the computer programming side of it, but it's gonna require some MATLAB, Arduino, things we don't really have access to yet as students in those computer science courses, but I'm working on things in Scratch to give you block programming to understand voltages and different levels, but the sourcing is just wow. So back to this. if we're looking at the problem that you need recovery of credit for, you want to go back to this. All right, I don't know if you see that. I think it says share. So let's start with this problem here, right? This is back on March 18th that I had posted. We want to take this due now, and like all problems, copy it. Now, what I'm going to do, I'm just copying the material, but understand, and I'm going to review this again at the end of the video, that you should not crunch the numbers based upon what I did. You should not copy and paste what I did and submit it. You should, and I say that very carefully, take the values that are given in the problem and use that to actually complete the problem. What I'm doing is a problem set, and I will change the values. I already have the problem worked out, you know, just to show transparency. I don't expect you to do, I don't know if you can see it, but a virtual background thing, I gotta fix that. I like it though. But my values are gonna be different from your values, is the point I'm making. And with that said, you're gonna have to redo the problem, type it up, or you can handwrite it, you know, write it down on a sheet of paper, and I'll take a picture of it and submit it. But if your calculations are on point, because I've already did the calculations, I already got the answer, then you'll get 100% credit. Now that includes the format, which is the Google Doc that I've always, you know, talked about since Q2. That is your header, the problem set, the problem itself, known and unknown values, and then of course, lastly, the steps that you did to complete the problem. You cannot just give me a final answer and expect to get full credit. That is piss poor performance. So with that said, I'm going to show you the steps on here. We should copy the problem. You can go into your student portal, move on to, let's start a new Google Doc real quick. So if you're logged in with your Gmail account, you can actually get access to Gmail, or I'm sorry, Google's accessories. You click on this icon that looks like 9 boxes. And if you come here to Docs, you can actually start a new Google document. Now, I'm pretty sure this is accessible on your cell phone, whether you're using Android or iPhone. So you just need a Gmail account though. So let's continue on. Click on blank. And I think you guys can see that, right? So you click on blank, you actually are able to now start your document as if it's a word processing document. I know a lot of people like to use Word, Microsoft Word, but the problem is when you use Microsoft Word, you're not able to actually share the document and everybody's able to work on it. And this is the steps I'm trying to get you towards, where if I share a document and you're online on Zoom, I can help you work through the problem. And you can take that solution and get credit the same day. But just like class, if you're not in class and you're not logging in to the Zoom video or any of the invites I give you, it's hard to give you credit because then you're gonna have to re-crunch the numbers by yourself. All right, I hope that's understandable. So let's go through some situations, right? What is the first thing you need? You need your header. I say this every time with all your reports you submit into your student portal. So let's start. That is going to be, I think I got the pull from the previous document. Zoom is in my way. Give me a second. It's this like top bar that really gets, there it goes, it went away. There you go. So I could take this from the credit recovery example video of previous and post this here. All right, so we can call this credit recovery 3. And the problem is actually on, where's my notes? This is the problem set for March 18th. We can check that right quick here. Right, so it's March 18th is the problem set. So I'm gonna type this in, but do know, again, I don't want you being, I did the same thing you did, I should get full credit. No, you only learn things by repetition and practice. So I need you to redo the problem that I just did with you on this video recording with your numbers, you're going to practice the problem, because a lot of students say, you didn't teach me nothing. Well, teaching comes with the want and desire to learn, and that only comes from practice. There's no substitute for that. Okay, so try to have these things at your fingertips, these procedures. So let's move on. I did the credit recovery 3. This is my header right here, right? Of course, you wouldn't put Mike Tyler, you would put your name. And of course, you wouldn't put credit recovery if you don't have credit recovery 3, you would put your period. And that's what I mean by period. What class do I have you for so I can give you credit in that specific class? Let's move forward. In ESB, this is the problem that I'm reviewing with you. So let's go through it. I'm waiting for Zoom to scroll up. Okay, because it has this anyway. So I'm going to post that there. And this is the current problem. But guess what? Again, we'll change this to the values I've already did on my own time during office hours. And you have to recalculate with these values, but I'm changing them now. So do know, if you just copy and paste what I did, it won't be correct. You'll probably get 50% credit. So let's go through it. 2.11 is what I'm saying for your magnetic flux. I just want that to be known, because I did this in the previous video and the prior video. I will do a hint or a clue of the problem, but I won't do the problem for you. That defeats your learning purpose. All right, so times 10 to the -4, that stays the same, and it's a Tesla meter squared. If the normal makes a loop in the angle of 55.8, so I'm going to change that to 59.2, and that's degrees. All right, that's the little circle above the number. And instead of 85 Teslas, I'm going to say 47 Teslas. All right. So now the question is changed. Again, reminder, and I'm going to do this again at the end, because students will be like, why I got 55%? Because you gave me a submission that was not complete. I gave you different numbers, but in the problem, you have the numbers. All you have to do is try the procedure to get it correct. All right, so please try not to finesse. Please try not to. All right, so this is a lengthy problem. Let me get through it. This also goes into accelerated technologies or particle accelerators. So it's an important problem, not just with the Tesla Roadsters. So let's go through it. The next step we need to do is develop the equation that we're going to utilize. Now, this is going to be tough, because some students are like, how do I write the little Greek letter with the I and a circle in the middle? That's, I think, phi, or it's flux. Well, in this case, for the problem set, it's called flux. And I'm going to try to, I don't know, open up here the equation for magnetic flux, just to give you a visual, because you're going to be like, what is that, right? So, definition of magnetic flux. There it goes. One second. And kind of get a good idea, but let's see here. Maybe Wiki can tell us the equation that I have in the book here. And you see that letter here is usually what confuses students, right? But this is magnetic flux in itself. And we're talking about electromagnetism, and this is the same thing that was discussed in the video feed or the YouTube video. And I'll try to post a link to that video later on with this video, so you can review it for yourself. I don't know if the sound quality was good or not. So if we scroll down here, you see, and of course, this is the equation I wanted. you have, well, not exactly, but you have magnetic flux, which involves the B field. That's what the magnetic flux means, or the B means. But if you come down, I'm looking for the specific equation. It's hard to show you here. But for the remainder of the problem, when I type flux in the problem, it's going to be just FLUX. I'm not going to be able to type this up and, for the sake of time in the video, find the symbol that relates to this Greek letter here. So let's keep going. Just wanted to make that known. So the equation, as you saw, I will tell you as best I can from typing it. And this is why I want to have an Elmo later, so I can just write it down and you can see what I'm writing. And then maybe later on, I can find physics chapters digitally to give you a better visual representation. But for the sake of explaining in time, it's FLUX for flux. And you can type magnetic, or you can say flux B, like they did. That's that symbol that I showed you earlier in the YouTube, I'm sorry, the Wikipedia article. So let's keep going. If we look at how that's equal to something, you say that's equal, and this is the equation I'm giving you for the definition. Let me type that up here. Definition of magnetic flux. In case students want to look that up on their own time, is equivalent to the B field, but this is called B vector. I got the solution written out here, but the virtual thing or whatever, I probably need to type that all up, or I really just want to do that digital. But the B flux, the B field or B vector, you should call it vector B, because that's what it is. And we can discuss why it's a vector later. This is going back to the previous video where I was talking about how you have the sunlight coming through. Did that help? Nope. I ain't gonna worry about it. All right, so you got basically the vector B is, let's put that in parentheses, multiplied by our, what's the equation we got here? Area multiplied, let's just type area, or maybe I should explain that. B field, this is the magnetic field basically. In physics and math, sometimes B field is what it is. So area, and we call that A, and this is multiplied by cosine, which is a trig vector, or a trig operation, trigonometry. I had tongue tied for a second. And we'll say theta. Now, theta is this like zero. Students get confused about that. It has a zero with a line through it. It's a Greek letter. It's theta, and it usually designates something that's a degree or angle or degree. So let's continue. We want to begin explaining some of these values, but I'm gonna have to explain it in transition because I think it's gonna be difficult to make the arrows like I did on my notes to show you what each one means. So I'm gonna try to walk through this slowly. If you got further questions, I'll try to scan later my notes and you can see what I mean, but for the moment and technological purposes, please just bear with it. So known values, right? We got our known values. What did the problem give us? And then our unknown. What is the problem asking us? All right, so let's go through it. We got this here, right? This is a known value. So circuit loop is 2.11 times 10 to the negative 4th Tesla meters squared, okay? With that said, where does that go? So if we look at our known values and this equation, come down a little bit. This is what we'll try to explain the dimensions for dimensional analysis purposes. So if I broke this equation up our flux is always measured in Tesla meters squared. And this will be equivalent to, not minus, equivalent to your vector B or B field. And your vector B or B field, in this case, is always measured in Teslas. This is going to be multiplied by your area, which is usually in meters, and that's squared. And this will be multiplied, of course, by cosine and spell that out for some people that don't know that, trigonometry and degrees. Degrees given. Now, I'm going to talk about this later because I'm going to do the calculation at the end with Symbolab. Some of my students who've had me in class, the veteran students, they remember we used Symbolab, and if you didn't want to use a calculator on a laptop, you punch in and I'll show you how to get an exact answer, especially if you're not familiar with how cosine works. Because if you use it in Google, what happens is you get radians answer, and then that gives you a bit of a headache for you and myself, because I got to make sure you got the right answer, and I only ask you for degrees, and you argue for some radians. It's a problem for a physicist or a mathematician. All right, so let's continue. You're gonna come down here, and what I'm trying to get you to understand is this here that I'm highlighting is the dimensions. Dimensional analysis allows you to make sure your math is correct structurally. And this is really important in the real world design for cars and electrical engineering, like you saw with Tesla, the statistics, because all data has to have a certain measurement category. That's why they have SI units and so on and so forth. They cancel out correctly. 9 times out of 10, the building that you are trying to construct with your mathematics won't fall apart on you. Just make sure you're not guessing. Just make sure you're doing your math correctly. Oh, let's continue on. We got, what am I looking at? The dimensions we're going to use, if we go through it slowly, are going to be what? We know for a fact that we're given a flux, right? It says the magnetic flux, if you see it here. Where's that at? Magnetic flux, right? Just telling you how to think through the problem slowly. Well, what is that? Well, if we keep looking, magnetic flux is going to be known as, 1 second, let me see if this works. That's too much. Oh well. So magnetic flux is going to be given as flux is equivalent to R 2.11 times 10, and we're going to use R raise it to an exponent -4, and Tesla dash M, or meters, and I'm going to say squared. This is just an abbreviation because I'm trying to, get the problem done for you. And now we have a theta, that's our angle, is equivalent to, what do we say? The angle we were given, well, we look here and that's 59.2 degrees. So 59.2 degrees. And what else are we given? Well, we're also given a magnetic field. Remember that B part I talked about, this B field? Well, that's what you're given here. So that's going to be, what we called that before in our problem earlier, vector B. So vector, we talked about vector before, B is equivalent to what we have, 0.47 Teslas. I think the Tesla's always capitalized. So now, what is the question asking us? You can look at this and see that it's going to be our area, right? So area is equal or equivalent to some number, question mark, that we're going to calculate, and that will be in meters squared. Again, that is a dimensional analysis type of situation. So what do we do? Well, now is the part where we have to actually do some algebra, and here's why. Let me rewrite the equation for you without the conceptual words and stuff. Just the mathematical explanation, so explanation, or sorry, representation, so that it can be it can be eliminated in a way that it leaves the area by itself or isolates the area. So what do we got? We got the original equation, flux is equivalent to our vector B, right? So instead of me retyping on this, I can just take it from here. This is the definition for equation. Let me say that you want to use, right? And then I want to take just this part here. Oh crap! Let's undo that. There we go. I'll take just this definition here. Down and boom, right? So we know this is vector B, that's what we'll call it, but I wrote this out so you'll know that's the B field. Look back at that later so you know where I got that from. This is my B field, right? And then area, right? You know that's what it is now, because I explained it. And theta, of course. And I don't want to write the symbol for theta because that's Greek. Just going to type it out what it means so you can type it out too and do your calculations. So let's come down one. Flux is now equivalent to what? We can do some algebra. This is the part where we do some algebra on this problem to solve for, what do we say, area or A. Now, you got to understand that area is a calculation that you learned about in geometry that requires you to use a radius, because we're talking about a loop. So area is equal to pi times r squared. We can discuss that later, or if you want my notes on it, I can provide that. But for the moment right now, we're treating area as a constant. And in the previous video, I talked about constants in terms of them being a solid value that doesn't really change. So area is a constant equation for a circular object, right, in geometry. So that's pi r squared. And that's why our meters are squared in the end if you look at area right now. But we're going to try to go through the dimensional analysis for you to see why it has to be that way in math. So let's continue. This is our next objective, right? So next, right? And what do we do? Well, let's rewrite the equation and begin working on it. So I'm going to take this here. Okay. And now I want to solve for, my area. Well, how do I do that? Well, I could take this entire thing and divide it by what I don't want around my area, which is A. So to do that, I put parentheses around. It's a computer science way, but I can explain later and show you calculations that I've done just by hand. That's why I want to get to Elmo, how to get rid of this. But this is the logical way of canceling out what you don't want. So now I'm taking the whole thing that I see and I'm putting it in a numerator, like it's a quotient, right? Next, I'm going to put what I don't want in the denominator. So in the numerator, I have the original thing that I'm working with. In the denominator, I'm going to have everything I want to divide out to cancel what I don't want. So that's why I put everything in parentheses above. I divide, and then what I say is in parentheses, I want everything in these parentheses to divide like I want it to. So I'm going to say, hey, I want to get rid of, for instance, vector B, right? Because I want to get A by itself, so I got to divide by that. So go ahead and take that and put that here. And I also, let's say, multiply by, because this is inside the parentheses. These are going to be together when they divide. I want to also get cosine away from that as well. So I'm going to take that, and I'll put this in the denominator. right? Or my computer science version of a denominator, right? So now what I have is something that will cancel out the vector b and the cosine theta. But again, what you do to one side, you got to do to the other. So I'm going to take all this over here in the denominator, and I'm also put it here. But okay, that's going to look weird, so I'm going to remove this and put it before that, because I want the flux to be divided by that. Okay? So far so good. Looks great the way this is set up. But now our new equation becomes what? Because things over here will cross cancel, and this is dimensional analysis part 2, but they'll cross cancel and leave certain things out and just area by itself. So let's see how that works, right? Let's rewrite our equation. Now these are iterations, as I say, and I'm gonna try to bullet them later because I forgot to do that last video. But now, what do we have? Well, this is going to stay the same, right? But over here, what changes for this entire equation? What changes? Well, like I said, vector b and vector b will cancel, if you can see all that. So I can just go ahead and remove that part. And what do we have? Cosine theta and cosine theta, right? You see it here in the top, which is my numerator, I'm thinking, using computer science stuff. And cosine theta, they'll cancel. So I really can just say, let's get rid of all that. So that's my new equation. Area is equal to the flux divided by vector b, multiplied also by cosine theta, which is whatever angle we're using. Let's continue on. I want to take this now and rearrange it. So I want to, write equations from left to right. That's how we do it in math. So I'm just going to take this here. Copy that, put that here, and then put this over here because I want to write the way I want to write. I want to write it correctly, like I'm a mathematician. I made a mistake. Go back, and I'm gonna put that there. And that's how the equation should look at this point, right? I think they just made that a bullet, and I didn't want them to do that. So just area. Does that work for you? Yeah. So area is now equal to that. So what do we got? We got our new equation for area, and this is what we wanted. We wanted our unknown to be this. And this will be once we plug in our values. So let's do that. So I end up with my area being equivalent to the flux. I just look up here, my flux, I already told you what it was, right? I pulled that from the problem that I made for you guys, but you have to go back and do your own. That'll be 2.11. Instead of doing all that, I can just do this. And that there, right? And what am I going to do with that? Well, I'm using my equation, right? So it's going to be divided by parentheses. Space that out so you can see it a little bit. Parentheses what? Let's put everything in parentheses we want to, multiply together. So I'm looking at my Teslas. That's going to be 0.47 T for Tesla multiplied by, and I got to put those in more parentheses because that's not going to work, but multiplied by cosine, open parentheses, what's the angle I gave? 59.2 degrees. Okay, so that's all fine and dandy, but if you got to be careful with computers. So let's group all this in the denominator. And what do we end up with? Right? Well, first let's do the dimensional analysis. Like, what dimensions cancel out and what are we left with? So if I look at this, I got, where we at? A Tesla here and a Tesla up there. Those cancel. Okay, so this is in the numerator. This one is in the denominator. They will cancel out. Degrees and cosine are really just degrees. They don't really affect dimensions. So I'll end up with meters squared. And if you look back up here to make sure the math's correct, it's meters squared. So that works out. Now it's just time to do the calculation. So let's do the calculation part. And this is the portion where I show you how to use Symbolab, online app for phone and for computer or tablet, where you can type up your calculations. So if I can, let's see if I can find it. I did it earlier. And this is the website Symbolab, right? Put the link in here so you can see it. Oh, I messed up. Yeah, still got my computer, got my original calculation. So now use Symbolab. Is it .com? You just do this. Okay. You can check it out later if you want. But this is the website I'm on, and let's go back to it for a second. Waiting for this to get on my way. So this is what I got. I got the answer already, but I'm gonna take you through the steps to do it so you can see how. Let's delete all this. Okay. Now, how did I type this in? Well, again, I'm using the equation from the previous page where we did the problem, right? So here, and then we're at this point, we're gonna type this in. So let's begin. Area is equal to 2.11 times 10 to the negative 4th meters squared, right? Because we got our dimensional analysis, we put it in here, note, so you'll know. Cross cancel. Via right, so you don't forget that part. A lot of students do not do that. You know what I meant. I'm like, no, I don't know what you're talking about. Kind of like, hey, and I'm like, no. So let's continue. So now I'll punch it in so you can see the final answer and how you generate it. If you don't have TI 89 or 95 or some type of engineering calculator to do this, you can do this online, just as simple as you type something in for the most viral video. You can do this for the most accurate calculation. So let's go through it. It's going to be, I'm going to use a quotient, and you just click on this. It makes a fraction for you. This is your numerator. This is your denominator. So in the numerator, I'm going to type 2.11 multiplied. I'll hold Shift and press 8. 10, and I want to raise it to a power. I'll raise it to a power. There we go. And let's say negative 4. Don't need dimensions because we're just making a mathematical approximation. In the bottom, I'm going to say 0.47, because our Teslas, multiplied by our cosine. Just click on this here. And where's cosine at? Shoot, it had cosine earlier. Full pad, there we go. There we go. So cosine, like that, and it's 59.2. So when I do that, I get everything they did, right? And the final answer comes to this. So it gives you the steps. This is a tool that I encourage students to use. These are kind of ed tech tools. You go online, use engineering tools like Wolfram Alpha, Symbolab, iExcel. These type of online tools and resources you can use to sharpen your blade and sharpen your students' mind in terms of what we're going through in this pandemic. You can still sharpen the mind while you're at home and not just let it go to waste, because the mind is a muscle. So let's take the final answer, finish up. So final answer and I usually have students box this because we're typing, you can't, is basically area is equal to or equivalent to, let me say 0 point, I wrote it down this time, so I have to flip the screen, 0.00087, and this will be meters squared, because we did the dimension analysis that you saw here, that is still meters squared once you cancel out all the appropriate dimensions. Okay, so that's where we're at. That's this at this point. You would submit this to your student portal. I will review it and I'll see if you do it with accuracy using your numbers. This is the reminder part that I said I was going to do at the end. You have to use your numbers to get full credit. You cannot retype what I did and just be like, I got credit. What's wrong with it? You know, you didn't actually practice the problem. You didn't do the problem. I gave you a similar problem. And in tutoring and education and all things, you have to attempt the problem to learn it. It's not going to come through osmosis. You have to try it out. So with all that said, you know, give it a try, submit it, and I'll still give you full credit. This is due to the crisis we're going in, but honestly, you got to try these problems. Okay. Let me just clean this up a little bit. The final answer. Okay, so I'm going to end this video and I'll try to present a video probably by either today or tomorrow on substitution method. The substitution method problems are very important because it shows you how to superposition or place or substitute one equation into another, linear equations, and get an answer for one and go back and get the answer for another, or ordered pair basically. So those problems are essential because it helps your understanding of all levels of mathematics under the branch of calculus. That's actually the pivotal point before you start going into calculus. Okay, so take a look at the video. I'm gonna post this to SB as soon as I can, and I'm also gonna try out posting this to Facebook. There's some students out there who they're older and they might want a refresher. Just reach out to me, current students, through the channels you do, and if you have questions, don't hesitate. That's all I'm saying, because I'm trying to make sure we finish this year strong. Plato courseware is due by April 16th. Enjoy your day, enjoy your time in this stay-at-home order, and also stay safe. Zim.